Greetings, Principles of Engineering. This lesson will cover the important concepts you will need to determine the mechanical advantage and efficiency of a simple machine or mechanism. Simple machines are essentially a compromise where we're willing to increase the distance where our effort is exerted in order to produce more force, or sometimes we may want the opposite. The 6 machines we will focus on include the pulley, inclined plane, screw, wedge, lever, and the wheel and axle. Mechanical advantage is a trade-off or a compromise between the distances and forces. We will examine mechanical advantage by comparing the ratio of the resistance and effort forces and the resistance and effort distances. Calculating ratios allows designers to manipulate speed, distance, force, and function. For example, what slope should a wheelchair ramp be so that the person in the wheelchair could easily manipulate getting themselves up the ramp? Let's take a look at this mechanical advantage example. We could lift this box up using straight from the ground, or we could get a little help using an inclined plane. Notice that when we lift the box with the inclined plane, the effort force, as shown by the red arrow, is 4 times less than the resistance force or the weight of the box. But when we look at the distances traveled, we notice that the box lifted using the inclined plane now travels 4 times the distance of the box that's lifted straight up from the ground. With this kind of a simple machine, we say the mechanical advantage is 4 to 1. Let's take a look at the idea of work. Work is the force applied on an object times the distance the object travels parallel to the force. Notice the 2 little lines beside the D. That just is showing you that the force and distance have to be parallel to each other. The thing with simple machines and work is that the product of the effort times the distance will always be the same regardless of the system's mechanical advantage. So even though you're putting in less force, the fact that you're traveling a longer distance, you'll end up performing the same amount of work. So what does the number of the mechanical advantage actually mean? If a mechanical advantage is greater than 1, that's the most common situation. In this situation, you will have less effort force and a greater effort distance, like this pry bar here, where we probably couldn't pull this nail out with just our bare hands, and we're willing to move a little bit further distance than we're actually pulling the nail out with in order to multiply the force that we're able to exert. Mechanical advantage equal to 1 is basically not a simple machine. The force and distance are both remaining the same. In the example you see here, we're just changing the direction of the force. Mechanical advantage less than 1 is an uncommon scenario, but sometimes due to the configuration of our mechanism, or if we actually want to multiply the force, we are okay with having a greater effort force and less distance, less effort distance. If you are doing some calculations and you have a mechanical advantage that's equal to or less than 0, you should recheck your work because that's not a thing. We can break mechanical advantage down into 2 different types, ideal mechanical advantage and actual. Let's take a look first at ideal mechanical advantage. This is a theory-based calculation. Friction loss is not taken into consideration, and the calculation is completed using distances or geometry. The formula that we use is IMA is equal to dE over dr, where dE is the distance traveled by the effort force, and dr is the distance traveled by the resistance force. The other way we can look at mechanical advantage is by calculating the actual mechanical advantage, or AMA. This is an inquiry-based calculation, which means we actually have to do a hands-on experiment to measure it. Friction losses are taken into consideration, and essentially it's the ratio of the forces of the force magnitudes. The equation that we use is AMA is equal to FR over FE, where FR is the resistance force and FE is the effort force. Once we've determined the ideal mechanical advantage and the actual mechanical advantage, we can use this information to calculate the efficiency. The efficiency is the ratio of useful energy output to the total energy input, or the percentage of the work input that is converted to work output. The equation that we use for this is we're calculating a percentage. So the percentage efficiency is AMA over IMA times 100%. For example, if we calculated an AMA of 2 to 1 and the IMA was 2.44 to 1, we could then use that information to calculate the efficiency, putting it into that equation. In this case, we would get an efficiency of 82%.